So we use MRI and magnetic resonance methods to look at systems of interest in chemical engineering, like reactors or porous media. And what MRI can do is it can give you information about what's going on inside a system without opening it up. So you can get images of where chemicals are being produced and where chemicals are being used up. And you can also get information about how fast they're moving and diffusing, which are all key aspects in understanding how reactors work. And if we can develop this understanding, then that means that we can also develop new ways to optimize these systems and to develop new reaction pathways, new reaction systems, so that we can then work out how we move from the systems that we're using now into the energy transition, where we're looking at producing similar types of products, but using new processes, using recycled materials, and form a whole sustainable circular economy. We use MRI, but we use it in a wide range of different areas which are applicable to the energy transition. Just a couple of areas to mention might be things like carbon sequestration for ways to reduce CO2 in the atmosphere. And one of the things will be trying to take waste and work out how we can produce valuable products from that, which can either be used as valuable products or go as feedstocks to these new processes. So we'll be looking at forming the same sorts of things, but with different materials. An area which I particularly wanted to talk about was that of production of synthetic fuels. So this would be a way to make sustainable aviation fuel. We're going to still need to have air transport for the foreseeable future. And at the moment, we don't have ways of propelling aircraft without the use of the high energy density that the current fuels use, so kerosene and fossil fuels. But there are ways to think about producing that type of fuel in a sustainable way. And the process that we're particularly interested in here is that of what's called Fischer-Tropsch. And this is a way where we convert hydrogen and carbon monoxide directly into a fuel that can be used in aircraft. And hydrogen and carbon monoxide can be obtained from sustainable sources. So using the MRI, we can identify how to optimize the reaction so that fuels that are coming out the bottom are optimized for and can be used easily for sustainable aviation fuel. Energy transition is of great importance to all of us, but as an internationally leading academic institution, what's important is that we're also seen as leading this transition as well. What is going to be vital is developing these technologies that we can use in the future. And that's what the university has great skills in, and with collaborators outside as well. And so using our skills and those with others should mean that we can be at the forefront of the transition and driving forward the changes that are required for net zero. We need to develop the processes that we've got, and we need to create new processes, and that requires chemical engineers developing their technologies to be able to produce what we need in a sustainable way in a circular economy.